Hey there, everyone! Welcome back to our channel. If you're passionate about technology, artificial intelligence, or machine learning, you're in the right place. Today, we're diving into a fascinating topic that's reshaping how we approach problems in AI, transfer learning. So, grab a snack, get comfy, and let's get started. So, what exactly is transfer learning? And why is it considered such a powerful technique in the field of artificial intelligence? Let's start with the basics. Imagine you've spent a lot of time learning to ride a bike. Once you've mastered that, you hop on a skateboard, and surprisingly, you pick it up pretty quickly. This is because the skills you learned while biking, like balance and coordination, transfer over to skateboarding. In the world of machine learning, transfer learning works in a similar way. It allows a model that has been trained on one task to apply its knowledge to a different but related task. This means instead of starting from scratch every time you train a model, you can leverage the knowledge from previously trained models. Let's break it down further. Typically, training a deep learning model from scratch requires a massive amount of data and computational power. However, with transfer learning, you can take an existing model that has already been trained on a large dataset and fine-tune it for your specific needs. This significantly reduces the time and resources required. Now, why is this so powerful? Let's look at a couple of examples to illustrate its effectiveness. First, consider image classification. Models like VGG16 or ResNet are trained on millions of images through a dataset called ImageNet. These models learn to recognize various features like edges, colors, and shapes across thousands of categories. Let's say you want to build a model to identify specific types of flowers. Instead of collecting thousands of flower images and training a new model from scratch, you can take a pre-trained model and adjust it. You can keep the earlier layers, which have learned to identify basic features, and retrain the final layers to classify your specific flower types. This could save you weeks of training time while still achieving high accuracy. Studies show that transfer learning can reduce training time by up to 90% compared to training from scratch. That's a game changer, especially for businesses and researchers working with limited data or resources. Another great example comes from natural language processing, or NLP. Models like BERT and GPT have been trained on vast amounts of text data, learning the intricacies of language, context, and meaning. Let's say you want to create a sentiment analysis tool that evaluates customer feedback for your product. Instead of developing your own language model, you can use BERT, which understands the nuances of language, and fine-tune it on a smaller set of labeled customer reviews. This approach allows you to achieve impressive results without needing a massive dataset of your own. Research has shown that fine-tuning models like BERT can lead to state-of-the-art results on various NLP tasks, often outperforming models trained from scratch. So, to summarize, transfer learning is a powerful technique in machine learning that allows us to leverage pre-trained models to tackle new tasks more effectively. By transferring knowledge from one domain to another, we save time, reduce costs, and often achieve better performance. To recap, the benefits of transfer learning include reduced training time, lower data requirements, and improved performance. Thanks so much for joining me today. I hope you found this exploration of transfer learning as exciting as I do. If you have any questions or thoughts about this topic, drop them in the comments below. And don't forget to like, subscribe, and hit that notification bell for more content like this. Until next time, keep learning and stay curious.